I want to talk today about our relationship with electrons and where that may lead us in terms of our thought processes about such things. Okay, so what makes the electron so special? Well, for one thing, it's the most common particle that we have any interaction with, really, on a physical material level, and it's negatively charged. Everything that we touch, the atoms that make the ends of our fingers and the atoms that make the objects that we touch, are coated with electrons. They're covered with electrons. These are the particles that guard the nucleus, so the very core of the atom is never going to be able to be contacted with by us or anything else that comes into contact with each other. So that essentially means that on that level we live in a negatively charged universe. Okay, so the question that might arise: this is the photon, the electromagnetic spectrum that the photon is responsible for. And that little Y symbol there is how the photon is represented in science speak. So any physics papers that you read that have got that in the equation, that's what it is, a photon. And we see this part. We get to visualize and use our sight with the visible light part of the spectrum. So that's the only thing that we can actually see in terms of what is going on around us. So what is happening here? Well, it appears that the mechanism for what's happening is that the photon is hitting the object that we're looking at, and then it's reflecting back to us a certain slice of the colour spectrum. It's doing that by bouncing off electrons. So if you think about it, all that the photon is doing in its complete traversal around everything that we do and everything that we essentially are, the photon is constantly bouncing off electrons in order to produce the effects that we see and in some way relate maybe to the effects that we touch. Because is this the photoelectric effect, this visible light slice of the spectrum? Is that what we're actually experiencing here? Are we integrating? Are we engaging with the photoelectric effect? Well, let's see what happens when the electron meets the positron. So here's the familiar electron that is negatively charged, and therefore the predominant charge in our universe, as I've just explained. And the positron, its opposite number, comes into existence from somewhere else that nobody really knows quite, pops into existence for one reason and one reason only, and that is to give up its energy, to be annihilated, destroyed. It gives up its life, in other words, to come into this universe and be annihilated by an electron. So that's this little diagram here of explosive natures, annihilation. When it does this, it produces a photon, amongst other things, because the photon then decays, as they put it, into other things. In one example I gave recently, the annihilation produces the photon that then decays into a quark and an antiquark and a gluon on the antiquark. But the antiquark doesn't exist in our dimension. The antiquark is in the antimatter dimension, going backwards in time, essentially. So it gets quite complicated, this stuff. If you go into it deeply enough, which I'm not going to today, because I just want to give a taste of what's going on here and the way in which we might think about it. This is our mood spectrum. Okay? So there's our interaction with photons and electrons and what's happening there. This is our relationship with ourselves, essentially. what happens inside us. Notwithstanding the possibility that this annihilation process is happening inside us, just as it is potentially happening anywhere in the universe that we live in at any given time. Doesn't seem to be any restriction on where annihilation can occur. It's just a force of nature. It's something that exists. So if it's happening inside us, let's have a look at this diagram and see whether that might correspond to anything that we could be familiar with. When we're up, we're happy, we're bright, sunny. You can use all sorts of glittery kind of words to describe how we feel when we're up here, when we're in a good mood. And then you might start to get a little bit blue. So you're moving into this zone now. And then you might start to get a bit of a darker blue, and before you know it, you're in a dark place. You're in what they call a dark place. And that can seem to last for some time when you're down there. In fact, it feels often like you're always down there when you're down there, and you're never going to get out again. That is the mindset of being in this zone, that everything is always going to be the same and is never going to change. Interesting that we have that polarity down there, because when we're up here, when we've come back out of this dark place and we come back through the blues and into the happy zone again, and we feel a bit brighter and sunnier, we have a feeling that, wow, we'd better make the best of this is great while it lasts, and make hay while the sun shines. We don't get this feeling of being trapped in an always never situation. We have a much better and more positive handle on the sense of time, our relationship with time. So where that goes is anybody's guess, really. But another thing to note is that when we're down here in this dark place and we move through these dark phases of life, we also correspondingly are said to have purple patches. And a purple patch is nice. It's up here. That's where we have a sunny bit to enjoy, and this is great. You know, the let's make hay while the sun shines kind of system comes into play, and we're having a purple patch. Does that correspond to UV light? Could there be any correlation between our sense of goodness and well-being and healthy forward movement in time? Could that have anything to do with the UV spectrum at all? Open question. Anyway, let's go back to the electron and what the electron does. Here's a representation of an atom, basically, in the kind of format that scientists like to present it in these days. Given that this is the nucleus, this is the neutron and the proton at the nucleus of the atom, and if this represents the electron shells, which I'm going to describe in a moment, then there is a huge amount of space between the nucleus and the first electron shell. Lots of space, apparently. Okay, so this isn't to scale, that's what I'm saying. But these shells, they represent energy levels that the electron has. So when it's in a shell that's close to the nucleus, it's said to be in its ground state. That's the lowest energy level that it can get to. To go up an energy level and jump from that shell to that shell, it has to take on a photon. So that's what happens. The electron will take on and absorb a photon in order to jump up an energy level. And then it will take on another photon and then take on another photon, so that it can jump up an energy level. There are subshells. So between these shells there are sublayers where the electron can, in some kind of quantum mechanical way, interact with that photon relationship in order for it to be able to orbit the shell valence. So it goes from ground state through to the next shell, up to the next shell, and then down again, and it orbits. So it's a whole system of orbiting, spinning manufacture, the atom, and those electrons are doing some really interesting things. They're going up and down in energy quotient just as we are, in our moods and our emotions and the way in which we view life are going up and down in our energy quotient. Now many people might say that this is completely irrelevant, has nothing to do with quantum mechanics, and because I can't write an equation on there for it, it doesn't exist. Fair enough, you're perfectly entitled to feel that way and think that way. I put these ideas forward to people simply to generate more thinking on the subjects, deeper thinking on these subjects, because they're important. So that's what this is all for, to incite some interest and spark some potential in where things might go. So, I hope you've enjoyed this, and it answers or asks some questions that might arise. See what you come up with, and have fun with quantum. I'll see you soon. Take care. Bye.